We're on lesson 9.4, factoring to solve quadratic functions. This is kind of a combination of what you did in chapter 8, where you factored polynomials, and what you've done in chapter 9, where you find the solutions to quadratic functions. The learning target today is to solve quadratic functions by factoring. So set up your Cornell notes and use this as your essential question. Just a quick review from yesterday, where we learned that these are the roots. And remember, these roots are where y equals 0. So really, if you wanted to find the roots of a quadratic equation like this one, you could let y equal 0. And all you have to do is figure out what value of x makes this equation equal to 0. Today what you're going to do is take a look at some quadratic equations, but you first have to remember a rule that's known as the zero product property rule. And basically what it means is if you're multiplying two numbers together and the two numbers multiplied together equals 0, what's true is either this equals 0 or this equals 0, or they both could be equal to 0. But it only takes one 0 in a multiplication problem to make the whole thing equal to 0. So if I have 7 and times 0, it equals 0. If I have 0 times 4, it equals 0. So just keep that in mind. And here we go. The first problem says, what are the solutions of the equation 4t plus 1, t minus 2 equals 0? So what you're trying to figure out is, what is the value of t that makes this equation equal to 0? And what's true is either 4t plus 1 has to equal 0, or t minus 2 has to equal 0. Well, all you have are two simple equations that you can solve. 4t plus 1 equals 0, t minus 2 equals 0. I'm going to start with the easier of the two, the t minus 2 equals 0. To solve this, you add 2 to both sides, and you get t equals 2. The first one is a little more complicated, but not really. Subtract 1 from both sides, you get 4t equals negative 1. Divide by 4, t equals negative 1/4. So the solutions to this equation, this quadratic equation, are t equals negative 1/4 and t equals 2. And that's it. Now, I don't know what the parabola looks like if I were to graph this, but I do know that it would cross at 2 and negative 1/4. So it might look something like that. So take a couple seconds. Here are some more practice problems. Hit the pause button, and when you're finished, hit play and I'll show you the answers. Okay, to solve these, all I'm going to do is set each of these binomials equal to 0. X plus 1 equals 0, and x minus 5 equals 0. Why? Because in order for this product, these two things being multiplied together, in order for this to be equal to 0, either x plus 1 equals 0 or x minus 5 equals 0. So I subtract 1 on this first equation, I get x equals negative 1. And I add 5, and I get x equals 5. So the solutions to this problem are negative 1 and 5. In the second problem, part B, I do the same thing. I just take each of these binomials and set it equal to 0. In the first one, I subtract 3 from both sides. I get 2x equals negative 3, and then divide by 2. In the second one, I add 4 to both sides, and that's my answer, x equals 4. So the solution for this one, negative 3/2 and 4. And as you can see, this is just a simple solving of algebraic equations. Now, if they stayed that easy, that would be great. We'd be done. But the next equation is just a little bit more difficult. What you have is a quadratic equation in the form x squared plus 8x plus 15 equals 0. And the question is, what are the solutions? So this just involves a few extra steps. X squared plus 8x plus 15 equals 0. I'm going to start by factoring that. And I'm going to factor it just like I did in Chapter 8. I'm going to set up my tic-tac-toe board. Two numbers that multiply to give me x squared are x times x. Two numbers that multiply to give me 15 are 5 times 3. And when I cross multiply, I get 5x plus 3x, which equals 8x. So this part of this quadratic function in factored form looks like this. X plus 5 and x plus 3. And that's equal to 0. Well, now that I have it written in factored form, I can tell you that one of these has to equal 0 to make the whole thing 0. So I set each one equal to 0. That will give me the solutions. Subtract 5 from both sides, I get x equals negative 5. And the second one, I subtract 3 from both sides, and I get x equals negative 3. The solutions to this equation, x squared plus 8x plus 15 equals 0, are x equals negative 5 and x equals negative 3. Those are the roots. This is a quadratic equation, and when you graph a quadratic equation, it makes a parabola. And by doing what I've just done, I can tell you that the parabola will cross at negative 5 and at negative 3. So if I were to graph it, 1, 2, 3, there's the first root, 4, 5, there's the second root. It will look something like this. Now we're going to get a little more specific in future lessons and graph it completely, but this just gives you a picture of what it looks like. Again, here are a couple more problems for you to work out on your own. Remember, you're going to start by factoring. And then setting them each equal to 0. So hit the pause button, and when you've finished, I'll show you the solutions. Okay, in part A, first thing to do is to factor m squared minus 5m minus 14. So you get m times m is m squared. Negative 7 times positive 2 is negative 14. And when you cross multiply, you get negative 7m plus 2m is negative 5m. So this factors into m minus 7 and m plus 2. Then you set each of these binomials, m minus 7 and m plus 2, equal to 0, and you solve. Add 7 to both sides, you get m equals 7. Subtract 2 from both sides, you get m equals negative 2. M equals 7 and m equals negative 2 are your solutions for this quadratic function. In the second one, p squared plus p minus 20. P times p is p squared. Negative 5 times positive 4 is negative 20. Oops, I got that wrong. Positive 5 times negative 4 equals negative 20. And when you cross multiply, you get 5p and negative 4p. Added together makes positive 1p. So if you write this out in factored form, you get p plus 5 times p minus 4 equals 0. Set each of these binomials equal to 0. Solve each equation. P equals negative 5 and p equals positive 4. And once again, what these solutions give you are the roots, or where the parabola crosses the x-axis. So if you drew a picture of this one, here's negative 2. 1, 2, 3, 4, 5, 6, 7. Here's positive 7. It could look something like that. A little more detail involved, but it gives you a general picture. 1, 2, 3, 4, 5. This is negative 5. 1, 2, 3, 4. And it could look something like that. And that's problem 2. In the third problem, you're pretty much doing the same thing that you did in problem 2. There's just one little extra piece, and that is in the first problems that we've done, you'll notice it's already set equal to 0. In this example, you're given an equation, but it's not equal to 0. You just have to make it equal to 0 by subtracting 18 from both sides. So you get 4x squared minus 21x minus 18 equals 0. And now you're pretty much doing the same type of problem that you did in problem 2. You're going to factor. You're going to get two binomials equal to 0, and then you're going to finish the problem. So hit the pause button and give this one a try all by yourself, and I'll give you the solution in just a second. Okay, to factor 4x squared minus 21x minus 18, you're going to multiply 4x times x to get 4x squared. Then you're going to multiply 3 times negative 6 to get negative 18. When you cross multiply, you get 3x. And 4 times negative 6 is negative 24x. Add those together, you get negative 21x. So this polynomial in factored form is 4x plus 3 and x minus 6. And to figure out the solutions, either one of these binomials need to equal 0, so you set them equal to 0. And then you solve. The first one, subtract 3 from both sides. You get 4x minus 3. Finish it by dividing by 4, and you get x equals negative 3/4. There's the first solution. Second one's much easier. Add 6 to both sides, you get x equals 6. And those are the roots or solutions of the equation 4x squared minus 21x equals 18. The last problem is probably the most difficult, mostly because it's a story problem. It also involves a little more work. But here we go. You're constructing a frame for the rectangular photo shown. You want the frame to be the same width all the way around, and the total area of the frame and photo to be 315 square inches. What should the outer dimension of the frame be? In other words, when you look at this picture, I want to know what x has to be, which is the dimension or the width of the frame all the way around. So if you look closely, it might be difficult to see on your screen, so I'll write it in a different color. The height of the picture is 11 inches and the width is 17 inches. That means the total dimension of the whole frame and picture from left to right is x plus 17 plus x, or 2x plus 17. And that means the total height of the picture is x plus 11 plus x, or 2x plus 11. So the area of this rectangular photo with the frame is 2x plus 11 times 2x plus 17, and that equals 315. So in this problem, really what you have to do is take these two binomials, multiply them together, get all the pieces together and set it equal to 0, and then go backwards. So it's kind of a problem where you go forward and then backward to get the answer. Here's what I mean. You're going to multiply out each of these binomials, and you get 2x times 2x is 4x squared. 2x times 17 is 34x. 11 times 2x is 22x. And 11 times 17 is 187. And that's equal to 315. So I'm going to add like terms. 34x plus 22x is 56x. Oops, not equals. I'm still adding to that 4x squared. I'm still adding 187, and that's still equal to 315. Now in the other problems, when we had this type of equation, we had to set it equal to 0 to find the roots. So I'm going to take the 315 and subtract it from both sides to get it equal to 0. And what I end up with is 4x squared plus 56x minus 128. And now you have a quadratic equation equal to 0 that you can factor so that you end up with two binomials set equal to 0, and then you can take each piece and set it equal to 0. Same steps as before, but like I said, it's just a little bit longer. We had to go through all of this multiplication, adding like terms, subtracting 315 from both sides. So let's go ahead and factor this equation. Now one thing that you should notice, or could notice right off the bat, is 4, 56, and 128 share a common factor of 4. So I'm going to factor that out first to make my other factoring easier. 4 times x squared is 4x squared, plus 4 times 14x is 56x, minus 32. Now factoring x squared plus 14x minus 32 is way easier than the first equation. To get that, I multiply x times x, which is x squared. To get negative 32, I'm going to multiply 16 times negative 2, which is negative 32. Cross multiply, I get 16x and negative 2x, which is positive 14x, which is what I want. That means my factors are x plus 16 and x minus 2. I can put the 4 out here. That would be correct, but it doesn't change my final answer. If I set x plus 16 equal to 0 and x minus 2 equal to 0, I'm going to get an answer of negative 16 and positive 2. Now that's great if all you have is an equation, but this isn't just an equation, this is a story problem. So let's go back up and remind ourselves what it is we're working on. The question is, what should the outer dimension of the frame be? You have two answers. Which one is the best answer? Well, you can't really have an outer frame that's negative 16 inches, so you have to go with the positive answer, which is 2. So let's make sure we answer the question correctly. It's inches. What should the outer dimension be? So the correct answer is the outer dimension should be 2 inches. And that's it. So really quick review. When you're finding solutions to a quadratic equation and it's already in factored form like this one is, just set each binomial equal to 0 and solve the equation. If it's not in factored form, then your first step is to take the quadratic equation, factor it, get an answer with two binomials, set them equal to 0, and get the solutions. Sometimes you'll get an equation that's not set equal to 0, so your first step has to be to get it equal to 0, like we did in this example. And then finally, you can use the same principles in story problems like this one to figure out how big your frame should be. Okay, the assignment for lesson 9.4 is shown on the screen. Make sure you make any marks on your notes to remind you to ask questions when you get back to class. And that's it.